Hello and welcome to week 10 of the spring 2026 programming with C# course. I'm Jim Kaufman with Rankin Technical College. So we're already at week 10. I know it's the weather's starting to get nicer outside. It's easy to find other things to do besides your schoolwork, but please please try to keep a schedule and stick with it, stay with it. It'll pay off in the long run. Right now, like I said, we're in week 10, so the finish line is closer than the starting line. So keep going, keep pushing, keep submitting your work. Everyone's doing great. I'm very happy with how everyone's doing this course, and please keep it up. So as far as assignments this week, we've got a hands-on test, which is due on 3/11 this Wednesday by midnight. And then we have Chapter 7 labs and a Chapter 7 written test that is due this Sunday by the Sunday 3:15 by midnight as well. So as far as what we'll cover today, we're going to go ahead and look at some Chapter 7 concepts, how to handle exceptions and validate data. And we'll look at some coding examples as well. And then tomorrow I'm going to present the Chapter 7 demos that's similar to the Chapter 7 labs. But I'll also make those coding examples available to you too. So both of them together can really help with the Chapter 7 lab assignments. So let's go ahead and look at the guide here. So what is an exception? So an exception is a runtime error, right? A problem that occurs while your program is running, not while it's compiling. So when something goes wrong, like trying to convert the text ABC to a number, the .NET runtime creates an exception object and throws it. Okay. If your code doesn't handle that exception, the application will crash. So I'm sure everyone has kind of experienced this. They just might not have realized it. You might have done something wrong and it might have compiled, but you put in a letter instead of a number and it failed, and you didn't set it up to handle that. You get an exception, and you probably didn't kind of really realize what was going on there. But there's ways to go ahead and handle that, right? And I do want to kind of mention, so a lot of things we do, we usually try parse that. We're kind of doing some validations to make sure we don't get exceptions, which, is really an important thing to do. But there's also certain circumstances where an exception will occur, even though you kind of tried to handle certain things. And from our perspective, we're kind of the users of our own apps, right? We're putting in data and clicking things. But sometimes applications get data from different places than just from the screen, right? You may have an application that actually makes a call out to the database, brings back data. Well, that data can be have some bad data in it, right? That could cause an exception. So in that case, you couldn't really do a validation where you send an alert back to the user, right? Because the user is a system, right? So you kind of handle things differently in that case, right? Because you can't send an alert back to the database or anything, right? That's the data that you got, and so what you can kind of do is you can catch exceptions, right? So that's just one example, right? But a lot of the things we are going to do here in our examples on Chapter 7 is we're going to create some of the same conditions that, sometimes we could actually handle it without exceptions, but it's important to understand that it is a mechanism to use, and it's very important to use it in a lot of other situations besides just entering data, right? So key terminology, thrown. So when a runtime error occurs, the system creates an exception object and throws it, meaning it interrupts normal execution and looks for the code that can handle the problem. Okay? Handle. So you talk about an exception. Are you handling your exceptions? So basically you catch an exception, right? An exception gets thrown and then you catch it, right? You catch that exception. using a try-catch statement, allowing the program to respond gracefully instead of crashing. Unhandled. So the concept of unhandled is if no catch block exists for an exception, the program terminates with an error message, right? Common scenarios that cause exceptions. So invalid format, right? Values too large. You can have a number that's too large for what you specified it as, right? So like this example, this is too big for an integer, an int, right? Division by zero, when you divide by zero, right? A null reference, the code tries to use an object that hasn't been initialized, right? It's null, so that's another one, right? So the exception hierarchy, all exceptions in C# are objects created from the exception class or one of its subclasses. So this forms a hierarchy. More specific exception types inherit from more general ones, right? So the top layer, base one, is the exception, right? And then there's other exceptions that inherit from that, right? There's format exception, there's an arithmetic exception, there's lots of other different exceptions. This is just an example of some of them, okay? And then arithmetic exception, there's different kinds of those, right? So overflow exception and divide by zero exception, or they're basically subclasses. An exception is a class as well, right? So these both inherit from arithmetic exception, and arithmetic exception inherits from exception, right? Same thing as we were just doing classes, right? Same concept. Real quick, let's go over to the Windows, not the Windows, but Microsoft C# language specification. Just look at here. It's, I highly suggest, you spend time. I probably haven't pointed you to the documentation as much, but it's very important. This is the true source of everything to do with the C# language is basically the Microsoft C# language reference documentation. So here's just kind of showing you, if come down a little bit, here's some common exception classes, right? It's showing you all of these, right? So here's a whole bunch of, these are just common ones, like I said, okay? So it's worth looking through that. Another thing is if you want to try out some things, right? You can go here, obviously you can do it within Visual Studio Code, but you can also come out here also to W3 Schools and try some things, right? And like I kind of mentioned before, we're just going to run this. Something went wrong. It's printing this out. So all that's doing is it's showing that you did a try, you tried this, something failed, and you caught it, right? We'll look into this more. But I just wanted to point out, W3 Schools is another option for you, and you can always change things, right? You can always change things and then run it again, right? Let's see what happens if we change it to a 3. What happens, right? Something went wrong. What if we change it to a 2, right? So you can sit there and play around, and there we did it right. Okay, so 0, 1, 2, right? For it's 0 based, right? So it worked that time, right? It printed it out. It printed out the number, right? So you can always play around it. This is good for just trying quick little things. All right. While we're here, I guess. So this shows and maybe we'll just come back to this here in a little while also, but this shows, this is an example of converting a string to a decimal where actually things can throw multiple exceptions, right? So this can throw an overflow exception, a format exception, an argument null exception. These lines can throw all of these different exceptions, right? So what you do here, and I'll mention this again here in a little bit, but you go from the most specific to the most general exception, okay? Overflow, then format, then argument null exception. This one is more general than this one, and this is the more specific one, right? So the way that works is you do a try here. If this throws this kind of an exception, right, it will go ahead and print this, right? If it didn't throw it, it's going to come, if it throws some kind of an exception, first it's going to say, okay, is the type of an exception a overflow exception? If it is, then go ahead and print this out, right? If not, go down to the next catch. Is it a type of format exception? If it is, print this out, right? And then here's the third one. If it's an argument null exception, print this out. And then actually you can always put the most general one is just exception by itself. And then that would be the one that you could put even after this one as well, okay? Now, reason you don't want to just put the exception one first is because no matter what kind of an exception it is, it would always just throw, because is it a type of an exception? If you just had exception here, right, the word exception, which is the base one, if you had that, no matter what kind of exception, it would always stop here and just throw that, right? Because it would be a type of exception, it would be that exception, because that's a general one, and so you'd never get to these other ones as well. So I'll talk about that in the future, here in a little bit, so make sure you understand that. But here's the different exceptions, and like I was saying, so like if you want to catch this one, right? You want to actually catch this one before you catch this one, before you catch that one. Because if this is the first one in your list, it's going to print out that one, and it's never going to do the others. So, but all exceptions of C# are created from the exception class or one of its subclasses, right? So this is just showing a few of them, right? So just showing these ones here, and add a couple other ones though. But format exception, a value can be converted to cannot be converted to a target type. So trying to convert a alphanumeric to a numeric, right? Like ABC to a decimal. That's going to be a format exception. Overflow exception, a value is too large or too small for the target data type. Okay. Divide by zero exception, an integer division or remainder operation has a divisor of 0. Null reference exception, code attempts to use a member of an object reference that is null. And then exception, this is the base class, can be used to catch any exception type. And that's why I was showing you in the code here, is you never want to have just this exception one, the first one. Which one was it here? You would never want it to be the first one here, because you want it to, like I said, whenever you catch multiple exceptions, you want the most specific one first and the most general one last, okay? Because otherwise, the most specific one, the most general one, it's always going to throw that, right? So this is going to test, is this actually an overflow exception? Is this actually a format exception, right? But everything's a regular exception, right? The base one. So that's one's always going to, is always going to trigger. All right. So why does hierarchy matter? Because the catch block of the exception will catch any exception, since all exceptions inherit from it. Like I've just said it a few times already, which a catch block for format exception will only catch format related errors. You use specific types first and general exception type last. So try-catch statements. The try-catch statements is a primary mechanism for handling exceptions. You place the code that might throw an exception inside the try block, and you place the code that should run if the exception occurs inside one or more catch blocks. So here's an example, right? So obviously there's no code here, but if this code throws an exception, right, then it's going to kind of test it. It's going to go to the first catch. Was this a format exception? No. If it is, it's going to go ahead and print whatever's here. If it's not, it's going to go check the next one. Is this an overflow exception? Right? If it is a flow overflow exception, it's going to print this out. Otherwise, it's going to go down to the next one. And every exception's always going to be, every exception thrown is always going to be a type of exception. So if these two did not catch, then it will go ahead and catch there. Okay. How try-catch execution works. When an exception occurs inside the try block, it immediately jumps to the first match catch block, and the remaining statements in the try-catch are skipped. They do not execute. If no exception occurs, all the catch blocks are skipped entirely, right? So if you don't have a more general one at the end that's always going to trigger kind of by default, right? Then your things your program's going to blow up just as if you didn't have a try catch block at all, right? So order matters, placing the catch block for the most specific to the most general. So catching a format exception. So here you've got a button convert click. You're doing a temperature do decimal, right? And then you're catching what's called a. Now certain things throw certain kinds of exceptions, okay? And we'll look at that in the code here in a little bit, okay? We can hover over it, and in the code, when we get to like Visual Studio Code, we can hover over it, and it's, it's usually at the bottom, it'll kind of show what kind of exceptions it'll throw, right? You can't just, you don't catch exceptions that something does not throw, right? Certain things throw certain kinds of exceptions, right? So we'll take a look at that, right? So in this example, the user enters something non-numeric, some letters. The convert to decimal throws a format exception, right? The calculation line is skipped, and the catch blocks displays a helpful message, right? Catching multiple exceptions, just like we've seen before. So sometimes things, and once again, if your code, if your code doesn't throw a certain type of exception, then there's no reason to have it in here, right? So, and like I said, we'll look at that when we get to the code. So this code will throw either a format, is possible to throw a format exception, overflow exception. And if for some reason it did not throw those types of exceptions, then, maybe there's some edge cache, it would actually always show the default one. So exceptions have certain properties and methods. So when you catch an exception, right, the exception object provides useful information about what went wrong. You access this information through its property and its methods. So we were seeing right up here, we did an EX, right, dot message. So this will print out the message of that exception, okay? We didn't do that for these other ones, right? You don't have to include this, but it's obviously very helpful, right? Especially as programmers, it's going to be helpful. Sometimes for users, you don't necessarily always want to show them things that they may not understand, right? Now you can, like we've kind of done some things where we put some, I know last week, and when I did chapter 14, 15, I had a demo that actually would print something in the log file, right? In the console that you didn't see, that you would not see from the screens, but it did print something, right? So that's a very, very good use of having an exception, right? Now this here, to a screen, we're going to look at that. We're going to do that. But for a user that's just using your application, doesn't know what any of that means, it's not really helpful for them. But we're going to still do that just so you can see how that works, right? So there's other things besides just message that you can do. There's also stack trace. This lists the methods that were called before the execution occurred. Extremely useful for debugging. It's a stack trace. It goes, this happened first, then this happened, then this happened. That's called the stack trace, right? What happened before my error, right? All the things that happened prior to that. Get type returns a specific type of an exception, right? Such as a format exception. A toString returns the string that combines the exception type, message, kind of everything together, right? You're doing a toString on that exception, kind of returning everything. So here is a example where you're catching just a generic exception. You're showing the message. Here you're getting the type. You're doing a toString on the type of exception, and you're also getting the full stack trace for debugging. Okay. So the stack trace property shows you the exact sequence of method calls that led to the exception. So think of it as a trail of breadcrumbs. It shows you where the error originated and how execution got there. This is invaluable when debugging. Okay, another thing that can be done is using a finally block. So a try-catch statement can include an optional finally block. The code in a finally block always executes. Okay, so if you recall earlier, we showed we have multiple exceptions, and only if that exception matches, right, is it going to execute what's in that block, right, between those curly braces of that, so if it's not a format exception, it's not going to execute what's in there, right? But for a finally block always runs no matter what, okay? And finally block is used for usually like cleaning up things, especially if your application uses a database, right? It makes a call to a database. When you call databases, even though we haven't gotten there, we're going to do a little bit on databases. Not a lot in this course, but we'll do a little bit here coming up in the next few weeks. But when you connect to a database, usually you have like an open connection. So when your application fails, you don't want to just leave that connection hanging, so to speak, right? You want to close that connection. So a finally block is a very good use for cleaning things up, okay? So when to use finally block is most useful when you want to clean up resources, like closing a file. Also we haven't done that as well. A C# application has the ability. There's certain classes that can be used to actually read files from, within your application itself. Grab data, right? So, or from other sources as well. But you can actually access files and the data in files. So when if you open a file, it can be open. If there's an exception, you need to close that, right? So closing a file, releasing a database connection, I already said that, or resetting the control state, regardless of whether the operation succeeded or not. So, and there's some things you can do also, since, you're using WinForms. Maybe you want to do some certain things to, no matter what, when you're done. If you catch an exception or you don't catch an exception, maybe there's some things you want to change or be reflected in your WinForms app, right? Your UI. So that's, you could do that as well, right? So in addition to catching exceptions, you can also throw exceptions yourself with a throw statement. This is useful when code detects a condition that shouldn't continue, such as invalid data passed to a method. Okay, so you can actually you can catch an exception, right? And then you can throw an exception, or you can just throw an exception by itself. You can say, if this happened, I want to throw an exception, right? And so there's some certain circumstances. Well, you can create your own exceptions too. We'll talk about that later. But if there's some certain things that happen, maybe you want to say, I don't want to continue. I want to throw an exception if this happens, right? It might be not something that automatically throws, right? But it may be something in your business model, something in your processing on how you want to handle things. If this certain condition happens, even though it's not a true exception from C#'s perspective, but from your business, that maybe your business process, you say, if this happens, I want to throw an exception, right? So you can use the throw new to throw a new exception. So here's some common reasons to throw an exception: testing exception handlers. Yeah, that's a good reason. You could throw an exception to verify that your catch blocks are working and working correctly during development. Method can't complete. When processing in a method that can't complete for some reason, required value is missing. You can throw an exception to signal a problem that's calling in the code. Rethrowing after processing. You can catch an exception, perform some processing like logging, and throw it again. So calling code can handle it too. The calling code can handle it too, right? Yeah. So this is kind of a little bit more of a more complex thing, is where you can have multiple classes, and inside this class it threw an exception. So you want to go ahead and throw an exception, and it's going to like kind of like bubble up to higher level classes. One class could have called another class, right? And each of your classes had different exceptions, right? So we'll look at that. Throwing and rethrowing. So here's an example. You're saying if discount percent is less than 0, or the discount percent is greater 100, you want to say there's an this is a this comes some business logic that you have, right? That you're just, hey, if this is the case, I want to throw a new exception here, right? So I'm going to throw a new exception. Discount must be between 0 and 100. Return the price, right? Okay. Yeah, this is kind of a little bit disjointed here, this example, but that's okay. So also there's the throw keyword. You can use the throw without an argument to rethrow the current exception. This preserves the original stack trace, writing the throws.ex, right? Resets the stack trace, making debugging harder. Okay. You don't do this in a lot of cases, but just kind of important to know. So now we're going to kind of talk a little bit about dialog boxes and the message box, which I think most of you have already. I think we had a couple examples. We used them already, so but kind of wanted to go through that a little bit more here. So the message box, this is kind of, especially when you start working with exceptions and you want to kind of relay some messages back to the window. Message boxes are very useful. So the message box class provides a show method which displays a dialog box to the user. This is commonly used in exception handling to display error messages, and in validation to notify users of invalid entries. So here you got a simple message where you just call them the show. Here's a message with a title. I thought read it with a title. So basically you're just, so this will actually put a title in your, we'll take a look at that too here in a little bit, live demo. So this will put an actually title entry error on it, right? So this will be the message, and this will give you a title to your message box. Message box with title, buttons, and icons. You can add other things as well, right? And so this is called a dialog result, okay? And you can do a show where you've got you ask a question and you can confirm either yes or no. And we'll take a look at those as well. But you need to make sure that you have something to close that. If the result equals a dialog result.yes, you need to be able to close it. So common message box options is message box buttons, okay, okay, cancel, yes, no, retry. Message box icon, there's also icons, information, warning, error, question. Dialog results, okay, cancel, yes, no, retry. So using dialog result, when you use buttons like yes, no, and the show method returns a dialog result. Value that tells you which button your user clicked, and can then use an if statement to respond accordingly. So we're going to take a look at some message boxes here in a little bit when we get done with the rest of this document. Data validation. So data validation is the process of checking user entries before processing them. Instead of relying solely on exception handling to catch the bad input, you proactively verify the entries are correct. Right? This provides a better user experience and prevents unnecessary exceptions from being thrown. Okay. Now that said, there are some certain circumstances you're not always going to be doing that, and there's probably we're going to be doing some examples where we could use data validation, not even have to worry about it, but we're going to be using exceptions anyway, just so you can kind of practice and learn how to use them as well. Okay, like I said, some things that throw exceptions are not always something that the user has control over, and that, like I was saying before, let's say your application calls a database. Well, what if something happens and a database is not accessible, right? That's not something you can send back to the screen or anything like that. Well, you can show there's a problem with this application, please try again, or please try later, right? Things like that, right? But, the way to kind of catch that is you catch a database type of exception, then you would present a user-friendly message back to the user. So 3 types of validation when working with text box input in a Windows Forms application. The 3 common types of validations you'll perform. Presence check, has a user entered anything, right? Numeric check, can the entry be converted to the required numeric type? Verify that the text box meant for numbers actually contains a valid number. Range check, right? Is the value within an acceptable range, right? And we looked at an example just a little bit up here ago where I think it was if it was less than 0, greater 100. So that's perfect for a range check, right? And so confirm that a number falls within the minimum and maximum values. This type of exception can also prevent overflow exception errors. And an overflow exception errors we talked about just a little bit. Like a number like you're passing in 10 billion into a integer, right? That's too big of a number, right? And you get an overflow exception. Why validate instead of just catching exceptions? Exception handling is a safety net, but it shouldn't be your primary strategy for dealing with bad input. Validation gives user specific helpful feedback about what went wrong. Quantity must be greater than 0 instead of a generic error message, right? It also avoids the performance overhead of throwing and catching exceptions, right? But sometimes another good reason to actually throw exceptions too is, like I mentioned just a little bit ago, back in last week when we did chapter 14, 15 labs, when I did the demos, I showed putting I think it was for an example of the different animals that we did, the animal search, and where we kind of showed the order, how it was doing the sort, and we actually put that in a console. And so sometimes you write things to a console that can be brought back. It's actually can be a log file that can be retained. So like, let's say, you had an application that the user was using and then it broke down. You could actually go back to your log files after the fact and see see what caused the thing, right? See what caused the error, right? And when you do like that exceptional handling try catch, you can catch that, show different messages, so you can come back after the fact and debug situations, right? Not just that, that's helpful when you got something in production where something's actually hitting it, right? And when you do that, you always have log files, right? Whenever you have a real production application that's in production, you have log files where things get printed to logs, right? And so when exception handle, using those try, catch, and exceptions, very, very useful for that, right? But, so back to this, exception handling is a safety net, but, you should really be trying to deal with trying to use data validation to check things, right? So here's an example of validating before processing. So basically, if our text quantity is empty, then we want to send that back to the user, right? But obviously, in a case like this, this is user input. If and you're only things like this, really not a good reason to have a log message, right? You just kind of want to send this back to the user. Hey, you forgot to do something, right? These are simple little things. These are always user related, where they just kind of didn't enter the right things, right? So that one was just checking if basically a text box didn't have the anything entered. Here's a numeric. You're trying to do a try parse here. So if you can't, we've done these already. So if you can't do it, then you show a message, right? And then you may want to do some other things as well. Put focus back in the box, right? And return. And it's important to also return to a lot of times, right? So if you got an error, no reason to move forward, right? If you don't have a return, it's just going to go to the next thing, right? Even though you put this focus here, without a return, it's going to just go to the next if statement. Here's a range check. If quantity is less than or equal to 0 or quantity is greater than 100, then basically you're displaying that to the user. And then if everything was good, you can go ahead and do your computation or whatever you're doing, right? So try parse versus convert. So there are two common approaches to converting text to a number. Understanding when to use each one is important for writing clean, robust code, right? So here, convert throws on failure, right? This is going to throw a format exception. And when I show you some examples here, we'll look where it'll actually tell you that this will throw certain types of exceptions. But this throws a format exception if it's invalid, right? So if you put in something that cannot be converted to a decimal, this is going to throw a format exception. So this is where you should use a try catch to handle that. Okay. Try parse returns true or false. Okay. So we've done these as well. Different ways to do things, right? We've done this where this returns false if invalid. No, this does not throw an exception. Okay. This will just return true or false. If true, then continue on, do what you want to do, right? Else it's false, right? All right. Best practice. So use try parse when you're validating user input. It's designed specifically for this purpose. Okay, and that's what we're doing most of the time. We're using WinForms. But sometimes there's other situations where you're passing things around. Once you get past it may not always be for user data, right? We start writing more complex stuff where we might call a method and we did something wrong in there. And it might not be something a user can fix, right? So there's other reasons that you want to do things differently. But best practice is when you're validating user input, use a try parse. It's designed specifically for this purpose. It attempts the conversion, returns true or false instead of throwing an exception. Use convert methods when you're confident the data is valid, like data from a database or after validation has already passed. Yeah, I question this comment right there. You really should never trust data. That's another thing I really want to harp on a little bit is never. I was always taught never trust data, never trust user data, never trust data coming into your application. You don't know who did it, where it came from. All kinds of things can happen as far as from a security standpoint, etc. So always validate data coming into your system. And same from a database. Someone could go and manipulate data. Some other, resource could have changed that data. It could have gotten overwritten by something. So I wouldn't always trust the data. So I kind of question that stating that there. But generic validation methods. When a form has multiple text boxes that all need similar validation, writing the same validation code over and over creates duplication. Instead, you can write generic validation methods, reusable methods that validate one entry at a time and can be called for each field. So why write generic methods? Generic validation methods let you reuse your validation code across multiple fields and then even across multiple forms. Instead of repeating the same checks for every text box, you write logic once and call it as needed. So here's an example. So returns true if some text box has an entry, is present, right? So basically you're passing in a text box and a name, right? And so if that text box is empty, then you show this message that this name is a required field and enter, and then in your show box, that's your title, right? But you're basically saying that this name is a required field, right? So that you can actually use this for multiple different fields on your form. Here's one checking for is decimal, same concept here. And then here's within range. So you can also write a method to see if something's within range. Then you pass in your different ranges, right? Here's your min, here's your max, right? Okay. 2 ways to use generic validation methods. Once you have reusable validation methods, there are 2 common patterns for calling them in a method that validates all entries in a form. Sequential with a early return. Basically, you're, maybe from your button click or something, you call is valid data, right? And then you basically go ahead and check everything, right? And basically if the first one fails, right, you return false, etc., right? This is kind of is present, is a decimal, is present for that. Okay, just an example here. Showing, you could do first, you do on the same one, the text price, you could do first, is it present? Is it a decimal? And then you kind of move on to something else, right? Or you can just do all together. This and this got to return. They all have to be true, right? This is a Boolean. Is it valid data? If they're all true, then it's valid, right? So this uses short circuit evaluation. Using the double ampersand, operator stops evaluating as soon as one method returns false, right? So if this returns false, it's not even going to check these other ones. That's what a short circuit evaluation is. It means once one returns false, because you already know that you're looking for these to be true. Using ands always, right? They're always used for Boolean, right? They're conditionals. They're looking for things being either true or false. And with an and, everything has to be true. If it's an or, right, all you need is one to be true, right? So if these were all ors instead of ands, if the first one's true, it's not even going to check the other ones. For and, it's the opposite. If one of them's false, basically it's going to check the first one. If this is false, they all have to be true, then it's just going to return false. It's not even going to check the others. Both approaches work the same way, thanks to short circuit evaluation. You're just forcing it here, right? If you don't return false, it would go to the next one. Okay, so validation stops at the first failure in either approach. Yes, that's true. calling a validation method. So just showing you a button click event where you're doing you're calling your is valid data. So you're not doing anything else until you know you got valid data. Is what you're doing, right? If this doesn't return true, you're never going to do anything else. So because is valid data has already confirmed the entries are present, numeric and in range, the convert calls inside the if block are guaranteed to succeed. No try catch is needed for those conversions. Putting it all together. In practice, you'll often use both validation, exception handling. Validation handles the expected cases, missing entries, bad formats, out of range values, while exception handling serves as a safety net for anything unexpected, right? So there's always some unexpected certain situations where, you don't account for that can throw an exception, and that's why you should always still do try catches and catch exceptions, so you can use them together, right? You should be using them together. You catch things, you discover things based on data validations, right? But then you also have a backup using your exception handling, right? Your try catch blocks. So this is showing an example where you're doing a try catch, right? And then inside here, you're also doing data validation. You're calling your is valid data method. So 2-layer defense. That's what I just said, layer 1 and layer 2. Okay. So real quick, an exception is a runtime error presented as an object. Create it when something goes wrong during execution. Remember, an exception is not something that you see when you get a build error, right? We've all had build errors before. And when you get a build error, that's not an exception, right? That's a build error. Your code didn't build. An exception is a runtime error when your application is running and you get an exception. Thrown, when a runtime creates an exception object and interrupts normal execution. An exception is thrown, right? You try, you catch. If you try and within that try, something happens, something goes wrong, it throws an exception, right? Then you have your catch block, which catches that exception. When a catch block intercepts and responds to a thrown exception. Stack trace is a list of methods that were called before the exception occurred. Okay, very useful for debugging. Try block contains the code that might throw an exception. Catch block contains the code that runs when a specific exception type is thrown. The finally block, remember that? So that contains code that always executes no matter what. All right, it doesn't have to throw an exception. It's always going to execute. Usually that's for cleaning up type things like databases, open files, etc. Also, you can, in your code, you can check if something like is in a range. You can say if it's not in this range, throw an exception. Okay, so you can throw an exception as well. Data validation is a process of checking user entries to make sure they're valid before processing. Now, from our perspective, I just kind of want to, talk about this a little more in a general. It doesn't necessarily have to be a user. It depends on what you're saying as a user. Data validation, you could be grabbing data from a database. You want to validate that data, like I said before, right? So any kind of a system, any kind of a file upload, right? You don't really have a user. It could be a file upload and your system reads this file that got uploaded, right? After the fact, and so, it's not necessarily always going to be a user entering data, right? So there's other scenarios as well for data validation besides, but, for most cases when we're entering, we're using win forms and users are entering data into a win form, then, data validation is very important for that, right? Presence check, presence check is validating the required field is not empty. Numeric type check, verify that an entry can be converted to the appropriate numeric data type. Range check, verifying that the numeric value falls within acceptable minimum and maximum. Try parse, we've all used those already, right? The method that attempts the conversion and returns true or false instead of throwing in an exception. We looked at message boxes, right? Message box show. And also for the most part, the ones we have done, we've done a little bit on that. We just kind of throw a message out there, but there's an optional title and buttons and icons and so forth, right? There's a little more functionality there. Generic validation method, very, very important, very intelligent, very good way to code, right? Just to use validation, generic validation methods where you can pass in the especially for like win forms, you pass in the text box, right? And then you have a name, what the name of it is. Then you have the data itself, and then you can actually check to validate if it's good or bad and return a message. So you can have one method that can check 30 different things on your thing, right? On your win forms. So, okay, so that's it for this guide. Next, I want to go ahead and go through a little bit different than just the demo. It's just kind of I want to go through these kind of concepts here a little bit. The demos that I usually do are more related to the labs, which I'm just going to look at some examples, which will still be related to the labs. But I'm going to look at some examples that we just kind of can go through and take a look at some of these things that we just kind of discussed here. So let's go ahead and do that here. Okay, first let's look at a basic try-catch. So got this simple little temperature converter. Here's kind of, let me show you the screen real quick. So here's a temperature converter, just converting from Fahrenheit to Celsius. Sound familiar? We've done that before in this class, right? So we're going to just do a simple converter here, and basically we have a try, right? So just remember when you do your try catch, you're going to be using your curly braces. And if you have a try without a catch, let's just see what happens there. So right here, expect it, catch or finally, okay? So you either have to have a catch or a finally block, right? Now you see this format exception, right? So if you hover over this, there's 2 decimal. You can see it throws 2 different kinds of an exception: format exception and overflow exception. Now, as you can see that this throws a format exception, does not catch, I shouldn't say it throws, it catches a format exception, right? It's a possibility that this 2 decimal would throw the exception, right? Now, by default, if you recall what we said, everything is going to exceptions to base class. So if you don't have format exception, it is still going, and you just had exception here, this should still work, right? So let's just get rid of the format exception. But you don't, some people do that. You really don't want to, you really want to be specific about your exceptions. You don't want to just use always the generic one. I'm just making a point here, okay? So here, let me close this and get this fired up again. So if I put some letters in here, hit convert, you're going to get the same thing here, right? But it's just proper programming to use this specific exception. And it really helps out with debugging as well. So you always use the specific exception that is being thrown, okay? Even though you can get away with this, right? I also wanted to mention, let me back that up. And let's just, not that you would do this, I'm just wanting to prove something. So if for some reason this threw some generic exception besides a format exception, what's going to happen there, right? So let's throw a new exception, and let's just do different exception here. And we'll close that out. Save that. Now, if we run this thing, okay, so it throws in a format exception, didn't catch. If it does throw a format, I've got to quit saying that. You know, it catches the format exception. If this code throws a format exception, right, this would be called, right? But since I have this here, it's automatically just going to throw an exception, the exception class, right? So is it going to catch this? If I throw this exception, is it going to catch it here? So let's see what happens there. All right, so let me fire this up. So here, let me just put a bunch of letters, hit convert. Did it not save this? This should not have worked. Why is it making me a liar here? Did I not save it? Oh, I think I know what I did here. Wrong. Let me check this out one more time here. Let me, before I even, I know what it is. So this is actually throwing the exception before it even gets here, right? This wasn't even being executed. So I kind of did that to myself. This isn't even being executed because I entered. So let me redo this again. Let me enter something valid so we know we get this far. So that's what was happening there. So let me just add, put 100, hit convert. And there you see, different exception. That's what I put in here. So this actually threw an exception, right? But we didn't catch the generic exception. We did not catch this, right? Like I said, you're not really going to do this in this case. I was just showing you an example of a situation where maybe it throws an exception besides that format exception. If you don't catch that, right, or you don't catch either the specific one or a general one like this, then so what you need to do here is you can also add a catch here, right? And we want to catch the what? The exception here. And right. I'll just copy this. And I'm just going to change this to different. Save this. Okay, now if I run this again, kill this, did save that. So now it's going to come in here when this new exception. So just pretend maybe that something else is happening that does not throw a format exception. You know, it throws something else. You didn't prepare for it. So by default, if any kind of an exception besides a format exception, it's going to call this, right? If you do a format exception, it's only going to call this. Anything else, it's going to call this now, right? So we're just doing this throw just to show you for example purposes. The only other reason you may want to also do this is like you may have something in your code, part of your business logic that it may be a range. And I think we had an example of that in the guide. If it wasn't between this value and this value, throw an exception, right? So that would be another use case for that. But real quick here, let's go ahead and run this. So I'm going to put valid data in here, right? Oh, I don't want to put that kind of valid data in there. And then to hit a convert here. And now it called that exception class. So I'm just want to, make the point that without this, it's only going to work with this format exception. Anything else, it's going to just crash, right? You're going to get that message that the application cannot proceed any further, so to speak. All right, so that was that one. Number 2 here is we're doing multiple. Right, so here's we're doing a format like we did, like I showed you. You hover over these, you can see what kind of exceptions they throw. Format exception, overflow exception. So there's your format exception. So the format is the more specific one, right? So you always make the more specific one. Then this one fires when the value exceeds the decimal range. And then here's your generic one, right? So now you've got your generic one here. Okay. The problem is it's hard, you got to come up with a very creative way to throw this just without actually forcing it like I kind of did it at least in the other example. But this one, basically the first one is format exception. Rate must be a valid number, right? So we can do that. We can put in a letter, produce a value that's too large, right? Okay. All right, yeah, so this should work here. If I go ahead and put a letter in, it'll fail here. Then if I come back a second time on the screen, so if I put it invalid, then this should go ahead and trigger this. Then the next time, if I make it valid, right, this should automatically, since this is a out of range type scenario, that this should fail, right? This is set up to fail right there. It's not thrown at equals infinity. Okay, so yeah, let's try that. So first one, we're going to go in here and put in this is the multi-catch, so we're going to put in something that's valid. Oh no, we're going to put something invalid. So it's, put in ABC, hit calculate, right? Rate must be a valid number, which was this exception right there, right? And then the next one, let's go ahead and put a valid number in. I don't think this is going to work by me just doing that, though. Okay. So actually, I do need to put this like this in here. So let me do that real quick. 0 dot, how many zeros? I don't know. Let's put a bunch of them in here. Now let me hit calculate. So this may, it's kind of catching this. Oh, there we go. You had to put a big enough number. So basically, so we put in a number, so it passed that first exception. It didn't throw that format exception, but it did throw the overflow exception, right? Rate produced too big of a number. Okay. And like I said, it's going to be hard to get here. Use a checked authoritative force overflow, yeah. So this is your general one. You should always have this as your last one. In case it doesn't throw the other, then it will go ahead and throw a generic exception. All right. The next one here is a finally block. Resources are cleaned up. We're just kind of simulating this. Demonstrates finally always is true. Always runs, always true. Finally always runs. Status label always updated. Okay. So just showing you a try and a catch, and then your finally. And it's just showing you that has run. Cleanup finally ran. So we're going to force an exception this time and run it. Simulate it, error thrown to demonstrate finally, but we're running finally no matter what. So if there's an error, it's going to run. If there's not an error, it's going to run. Okay, and then we already kind of looked at throw here ourselves a bit ago. Let's see, throw. So what we're doing here, where are we doing that? This doesn't really do that quite like I thought it would. Throw statements and discount calculator. Oh, a new argument exception. This is just showing an argument exception. So here we go. So this is basically you're trying to calculate a discount. Price cannot be negative. So if the price is negative, it's going to throw a new argument exception, right? So this is calling a method can throw an exception, right? And then it will be caught. It will be caught by um, this, right? It will be caught here. If this throws an exception, it's going to be caught right here, right? So we're just doing a negative number on that. So that was tab number 4. Let's take a look at that. Price cannot be negative. Argument error, right? Test rethrow. Caught after rethrow message. The input string, not a number, was not in the correct format. Format exception. Get type. All right. Here's just some different message boxes, just so you can and you can look at these different ones. So here's basically a simple message, right? Here's one with a title, entry error. Here's one with a yes or no questions. Yes or no. Are you sure you want to continue? A warning icon. Here's one with an error icon. So all different options there. And then here's a little different examples on how to do those by using match icon equals warning, or you can do the different button options, right? There's the yes, no, the okay, cancel. There's the okay one, right? So there's multiple of those. All right. Inline validate. So here we're just doing inline approach, demonstrates a present check, try parse. So basic stuff we've done before, you basically checking to see if something has got a value, is it present? If not, we're going to show the message box, right? We're going to show the error in the message box. Things we've done before, a lot of times we're using labels for errors, or, we did do a little bit of message box stuff, but just the same thing here. This is doing a numeric type check, and it's usually actually showing a warning message, right? Here's a range one, where you're doing the same thing, showing a warning. OK button. So all validation passed. Just remember, if you're ever doing, and we've kind of talked about this in the past, but if you're doing a bunch of if statements, if something happens, you don't really want to unless you're wanting to catch all the errors and bring all of them back at one time, which sometimes is something you want to do, but not all the time. If you always want to, somebody puts something in incorrectly and you want to catch that and just have them fix that, then you need to make sure you have a return right away. So if there's an error, you return that error. And then if the second one's a problem, you return right after you discover that that's a problem. Same thing with the third one, right? The other way is to kind of have an array of errors, right? You're going to catch you do all these validation and you add this to an array of errors, and then you bring that back and display all errors to the user, right? So you have different options on that. All right. Generic method. So let's take a look at that. So basically you're using this is valid data. We've looked at this kind of in the guide. Right? So we're checking if something's present. We just go one after the other, right? It's either going to be false or true. So this is kind of a sequential approach, right? And you just basically, if there's a failure, once one fails, then it's going to bring that back. It's not going to check the others, right? let's go back up here again. That's fine. All right. Validation first and then exception handling. So this is showing that, besides just doing this validation data to do, you also, very important, and really need it. You should always have a try catch for anything that could potentially return some kind of an exception, just in case for some reason your code didn't catch that, right? Obviously, when we're doing simple little things, you're doing one try parse. There's not much of a concern with that if you've handled that correctly, right? Most of the time it's not. But, a lot of times we have much more complicated codes doing different things. And there might be some piece of code in there that throws an exception that you're not really accounting for so much. And so you want to make sure that you always kind of, you don't think it's going to be a problem, but there's always these little edge cases that, for some reason it is a problem. So you always kind of want to try to do that. So here's kind of a more of a generic one, generic method where you're basically passing in the text box and you're passing in the name and you're just saying, hey, this is a required field, so this can be reused, right? This is good, nice generic method. And this one is for is this decimal, is int, etc. Right? And here's also within a range, where you pass in a min and the max value, determine if it's in a range. Another nice little generic method. So let's just kind of look at these real quick and be done with that. So here's a price. Nothing really to show on that. You can put breakpoints if you want to look at that. Try parse or versus convert. Let's just kind of talk about that one more time here. Okay, let's go down to that one. So try parse, right? So basically, two different ways two common approaches to converting text to a number. So convert. So a convert's going to throws on a failure. A convert's going to throw on a failure, where try parse returns either true or false. So here's a try parse. It's either going to return a true or a false, right? So you got an if or else on that, and then here's your convert. So convert throws, it's going to throw an error on failure, right? And so you're try catching this for a format exception, right? So since you're doing a conversion in that way, you're doing the convert, you need to do a try catch around that, right? And so it could potentially throw a format exception. So that's a convert. Obviously, in most cases, try parse is probably better in most cases, especially for form data. Okay. So that's all I have, and I will make this also. This is kind of a little bit different. Usually I just we go through the guides and I do the demos that's associated with the labs, but kind of have this other one here. So I'll go ahead and make this available too out there in the GitHub repository, so you can take a look at that as well. So that's all I have for today. Please let me know if you have any questions, and have a great day.